Profiling can feel overwhelming at first. Those graphs and numbers can feel like a lot to take in. But don't worry. Today I'll guide you step by step through profiling in Unity so we can spot and fix performance issues to build a smoother, optimized game. I'm Anand and let's jump right in. The Profiler in Unity is a powerful tool that tracks what's happening behind the scenes in your game. You can open it under Window, Analysis, Profiler. It essentially acts as a tracker. With the Profiler open, make sure the record button is on and then hit play. You'll see graphs and data starting to move. Click on the graph to pause the game and analyze that frame. At the top of the Profiler, we have the graph. It's like a live overview of your game's performance. Different modules here represent systems like CPU usage, rendering, and memory, showing you how much processing power they use. You can click here to disable modules to improve in-editor performance. The timeline view at the bottom gives a detailed breakdown of what each system and function is doing frame by frame. This is great for pinpointing exactly when and where issues occur. Switching to the hierarchy view lists every function and task in your game, sorted by processing time. You can expand functions to see which ones are causing spikes. Okay? The raw hierarchy and inverted hierarchy views are less critical for beginners but useful as you gain experience. Typically, you'll switch between timeline and hierarchy while profiling. The deep profile option captures detailed information about every function call but is resource intensive, so only use it for specific, hard to find issues. Call stacks show the chain of functions leading to a specific call. Guys, don't worry about these two options when you're starting profiling, okay? Just turn them off. Don't worry if it feels like a lot right now. By the end of this video, you'll know exactly how to make sense of these insights. Now that we have covered the basics, let's dive into the 7-step process for identifying and fixing performance issues. This is a fake example, but you can follow the same steps even in complex scenarios. Step 1. Identify the spike. Start by hitting play and looking at the profiler graph. Noticeable spikes in CPU usage are the first sign of an issue. In this example, the spikes are everywhere. Step 2. Check the highlights. Select a frame and click on highlights to see if you're CPU bound or GPU bound. We are CPU bound here, and this means we need to fix some things with the CPU. Step 3 is to find what's causing the spike. To do that, we switch to the hierarchy view to find the function taking the most time. Here we can see that script behavior update is taking time. We can expand this again and again to figure out that there is some function that is about logging. And if we look at it, it is inside one of my scripts which I have intentionally made called Spike Simulator. This is what's causing the spike. Step 4 is to find related game objects, if any. Here is something really useful. Switch No Details to Related Data in the Profiler. This highlights any game objects linked to the issue. For Spike Simulator, if we select it, we see it's a part of the game manager. Really useful, right? Step 5 is to use AI assistance. Sometimes you'll see functions or terms in the profiler like wait for target FPS, render opaque geometry, or player loop that might be unfamiliar. If this happens, you can use AI tools like ChatGPT or Microsoft Copilot for quick insights. For example, you could ask, why does wait for target FPS affect performance in Unity? Or how can I optimize processes in the player loop? This can help you better understand these functions and find ways to improve performance. Step 6. Make changes. Once you've pinpointed the issue, implement fixes. In this case, reduce the number of debug.log calls or only log at specific intervals instead of every frame. Also, move the intensive calculations outside of update, perhaps to a coroutine, or execute them less frequently. Step 7. Reprofile to verify. Once you've made changes, rerun the profiler to confirm that your fixes are working. Profiling is often an iterative process, guys, so don't be afraid to go through these steps again if you notice other spikes later on. This is probably not the best way to profile, but I just wanted to give you a step-by-step process which you can follow easily. With time, you would want to learn more about things like deep profiling and call stacks. All of these are things that you should learn over time. You should not take all of these head on because it can be overwhelming. Just focus on small steps at a time. Alright, once you're comfortable profiling in the editor, it's time to profile build versions. Before that, we need to set a target frame rate. You'll notice some lines in the profiler graphs. They are frame times that show you how much time a single frame should take to execute. So we need to set application.target frame rate to match your platform's requirements. Also, we can set the target frame rate in our profiler by clicking on this button here and setting it to custom. This will help us with the highlights module. For PC, aim for at least 60 FPS or 120 FPS for competitive games. Consoles, set 30 FPS for older consoles and 60 FPS for newer ones. Now VR is a bit of a different animal. Use 90 FPS minimum to avoid motion sickness. This might mean making some compromises on game mechanics to keep it smooth. For mobile, 30 FPS is acceptable, but 60 FPS is ideal for fast-paced games. But mobile has a unique challenge: overheating, also known as thermal throttling. If every frame is super packed with tasks, the CPU will constantly work without breaks, resulting in rapid overheating. We can avoid this by introducing a cooling time within every frame. If you target about 35% below the budget, say around here, the CPU will actually get a bit of waiting time. By the way, we can get the exact number by multiplying this one with 0.65. Now, this waiting is a good thing, especially when it's at the end of the frame, giving your CPU a breather and allowing it to cool down. Now, as you look through the timeline, you might notice markers labeled wait, which can show up in yellow, green, or gray. These waits represents moments where different systems like the CPU or GPU are waiting on each other. For example, yellow usually means the CPU is waiting on the GPU. While these waits are often normal, they may still cause spikes. So use AI to figure out why. It's so much easier that way. Okay, now let's profile the build. When building your game, enable development build and auto connect profiler to profile directly in the build. And if we open the game, the profiling will start in Unity. Now we can see that the game caps at 60 FPS, but in the editor, it will be way faster. Why is that? This is because of VSync. VSync is on by default for PC builds and it is disabled for mobile. My monitor has a 60 Hz refresh rate and hence the 60 FPS. You can see yellow markers in the profiler as well. All of these are waiting functions that exist because of VSync. I know this might be confusing, but if you would like a thorough video on VSync, please do let me know in the comments. And yeah, for profiling, we redo our 7-step method here as well. Just to recap, we identify the spike, check the highlights, find out what function is causing the spike, then identify related game objects if any, use assistance from AI to figure out why it is happening, then make changes, and we repeat and reprofile. So here are some bonus tips. Start profiling early and often. Fixing one problem at a time is way easier than fixing 100. Additionally, while using version control, profile before and after adding new features and include performance notes in your commit descriptions for better tracking. There you have it, profiling in Unity. Let me know what you would like to see next, and I'll see you in the next one.